Hello friends, welcome to Engineering Funda family. In this video, I am going to explain you structural hazards in pipelining. Here in this video, I'll explain you two different examples of structural hazards, as well as I'll explain you how we can resolve issues of structural hazard. So first of all, to explain you structural hazard in pipelining, let me consider one pipeline which is having 4 different stages. So if you observe, we are having 4-stage pipeline. First stage is instruction fetch, second stage is instruction decode plus operand decode, third stage that is execute instruction, and fourth stage that is write back. Now I am going to explain you one example in which I will be executing 4 instructions with respect to this 4-stage pipeline. So first of all, let us consider a case in which there is no hazard, right? So what I'll be doing is I'll be executing these instructions with respect to this 4-stage pipeline, right? So first of all, there will be first instruction that is getting fetch over here in first cycle, that is IF. In second cycle, what will happen? Instruction decode will happen with first instruction. In parallel with that, instruction 2 that is getting fetch over here. In third cycle, this first instruction that is having instruction execution stage, and in parallel with that, second instruction that is getting decoded over here, and third instruction that is getting fetch over here, right? In fourth cycle, what will happen? This I1 that will be having write back stage. In fourth cycle, this I2 that will be having execute instruction stage, and here this I3 that will be having instruction decode stage, and in parallel with that, you will be observing this I4 that is getting fetch over here. Then you will be observing this second instruction now that will be having write back stage at fifth cycle, this I3 that will be having execute instruction stage, and this I4 that will be having instruction decode stage. In sixth cycle, what will happen? In sixth cycle, you will be observing this I3 that will be having write back stage, and this I4 that will be having execute stage, and in seventh cycle, this fourth instruction that will be having write back stage, right? That is how this pipeline structure will function. But here let us consider one issue which is happening with I1. Let us say I1 is there with memory instruction, right? So what will happen? Because of I1 is memory instruction, you will be observing in write back stage, it will be using memory. And you see at fourth cycle, what is happening? This I4 that is performing instruction fetch. So in that also it needs to use memory. So you will be observing this I1 and I4 both are using memory in fourth cycle. So do you think it can execute this instruction? Simply no, it cannot execute this instruction during that time period. Why? The reason is both instruction needs memory. You see here we are having processor and here we are having memory. So you see first instruction that is doing write back of memory, right? And second is reading instruction, right? So do you think read and write both are possible over same buses over here? No. So here there will be issue. So here this issue is referred as structural issue. Why? The reason is same memory that is been utilized by 2 instructions. So that is not possible over here, right? And this is what structural hazard. Structural hazard means same resources cannot be utilized by 2 different instructions, right? That is referred as structural hazard. So in this case, how to resolve this? So for that, simply you can go for Harvard architecture. In Harvard architecture, what will happen? This memory that will be separate for data and code. Let me explain you that over here. Now my dear students, in Harvard architecture, what we do is for data and for code, we will be having separate memory. You see this instruction fetch that is utilizing which memory? It needs to have code. And with this write back, we will be using operand, right? So for that, you need to have data memory, right? So here in Harvard architecture, what we do is with this CPU, this memory that is separate for data and code. Here you see data and code both are there in same memory. That's why this buses cannot read and write at the same time. But in Harvard architecture, you will be observing this CPU that will be having two memory. One memory is there for code and second memory that is there for data. So now because of we are having two separate memories, at the same time this write back and instruction fetch that we can have, right? Now my dear students, it is not about only structural hazard is there with memory. There can be other structural hazards as well. Like as if you have instruction which is having multiple cycles for execution, then you will be observing in pipelining there can be issue. Let me explain you that by example so that will give you more clarity. Now my dear students, what I'll do is I'll explain you one practical example in which I'll be executing two instructions. One instruction is there regarding multiplication and second instruction that is there regarding addition. So first what I'll do is I'll execute multiplication instruction. So if you observe here, this instruction 1 that is there regarding multiplication and second instruction that is there regarding addition. Now when you talk about multiplication instruction, then you will be observing initial stages, right? Like instruction fetch, instruction decode, that will be taking same cycles. So I'm writing instruction fetch, instruction decode, but execute stage that will be more with multiplication instruction, right? So you'll be observing with ARM7 there are 3 stages for execute instruction, right? And then there will be write back over here. Now when you perform addition instruction, at the time it will be having only one stage of execute, right? So you see what will happen here. When it performs instruction fetch and instruction decode, at that time there will be no issue. Why? The reason is, see, instruction decode that is getting performed by I1, at that time instruction fetch is happening. When execute is happening, at that time instruction decode is happening. So during this time period there will be no issue. But if you observe over here, you see now we want to perform execute instruction. But here you see ALU is busy for execution of first instruction, right? So during this two time period, you will be observing you cannot perform execute I2 instruction over here. After this only you are allowed to have execute stage, right? So here you will be performing execute and then you will be performing write back over here. So here if you observe carefully, see these two clock cycles are stalled. Why these two clock cycles are stalled? Because of we are having only one ALU. So solution is you can use multiple ALU, but my dear students, it will increase cost as well, right? So generally when structural hazards comes, at that time sometimes we can resolve some problems by having compiler, efficient compiler that you can say, right? As well as by having Harvard structure, you can eliminate the issues of data and code memory interface with each other, right? So that is possible. But when it comes to complex instruction, at that time definitely there will be structural hazard. Like as I have told you over here, you cannot have execute stage. Why? The reason is ALU is busy for a performance of first instruction, right? So that is how structural hazards are happening. I hope it is clear to you, and these concepts that will be using it in solving problems. Still, if anything that you like to share it with me, please note it down in comment box. I'll be happy to help you. Thank you so much for watching this video.